Welcome to Honors Geometry 2.3, the laws of logic, where we try to teach you how to become a logical thinker and try to move away from inductive reasoning, which has its uses, but we're going to move away from that. Before we do that, one quick definition. Perpendicular lines, two lines intersect to form right angles. From what we've already learned, these will end up being four right angles. Upside down capital T is a symbol used for perpendicular, and we would write line M is perpendicular to line N, forms right angles. Perpendicular. Alright, I got a paragraph for you to read, and then we'll move on. So go ahead and pause and read it. You may need to write it down. I don't know. Moving along. I guess what I wanted to definitely point out to you is that you look at specific things and make a general statement with inductive reasoning. In deductive reasonings, we look at general statements and make a new specific statement. That's part of the difference, which makes deductive reasoning a little bit more powerful. So let's go ahead and talk about the laws of logic. The first law of logic is the law of detachment. If the hypothesis of a hypothesis, wow, got Theodore Geisel going through my head. If the hypothesis of a true conditional is true, then the conclusion is also true. And let me show you a couple examples. You ready? Example 1. If two angles are complementary, then their sum is 90 degrees. You know what? I'm not sure you can read that over on the edge there. There we go. Okay. Angle A and angle C are complementary. We should be able to come up with a new specific conclusion talking about angle A and C. Yes, that new conclusion is the measure of angle A plus the measure of angle C equals 90. Next example. If two lines intersect, their intersection is a point. Line L and line M intersect. Your new conclusion, not going to say their intersection is a point, you're going to say line L and line M intersect at a point. Very specific conclusion about L and M. We don't want to use pronouns in there at all. That's the law of detachment. It's like the hypothesis and the conclusion are detached from one another. That's why it's called the law of detachment. Up here in this if-then statement, the hypothesis and conclusion are attached together, but when we look at specific examples, those are detached. The next law of logic is the law of syllogism. It, in words, says, if two conditionals are true, and the conclusion of one is the same as the hypothesis of a second, then you can write a whole new conditional statement, a new if-then statement, using the hypothesis of the first and the conclusion of the second. Here comes your first example. If two segments have the same length, then they are congruent. If two segments are congruent, then they can be marked with tick marks. Okay? Notice that, here I need to get my pen, hold on just a sec, just show a little patience. There we are. Whoops, wanted red. Notice that this conclusion, they are congruent, and two segments are congruent. Those are exactly the same. So what we're going to do is we're just going to ignore that conclusion and that hypothesis and write a new statement that says if two segments have the same length, then they can be marked with tick marks. That's what the law of syllogism does. Just that easy. Here's another one. If it is raining, then the baseball field will get wet. If the baseball field will get wet, then the game will be canceled. Notice that, again, the conclusion of the first one is the same as the hypothesis of the second one. And that's kind of what we're going to make go away and disappear. Then we can write a new conditional, a new if-then statement. If it is raining, then the game will be canceled. And that really is how easy the law of logic is. If x equals 5, then 12x equals 60. If 3x minus 2 equals 13, then x equals 5. Notice that this conclusion right here is exactly the same as this wait, no. That's not it at all. What are you going to do when you come across something like this? Instead, you're just going to do a little itty-bitty shenanigan. And in your brain, or on your paper, you're just going to switch the positions from the first conditional, turning around and making it the second conditional. And as the French would say, voila. Yeah, I know it's voila. They can't pronounce anything correct. Here you've got the conclusion, x equals 5. Here you have the hypothesis, x equals 5. Our new, cool conditional statement will be if 3x minus 2 equals 13, then 12x equals 60. It really is that easy. Sometimes you need to switch around the statements to use the law of syllogism, but that's it. This does conclude Honors Geometry 2.3 Conditional Statements.